assumptions. You're guaranteed you won't have policy oscillations. When the rules don't hold, you aren't guaranteed to have policy oscillations, but policy oscillations are possible. There's actually a whole line of research that shows that even just in the absence of something like the Gao-Rexford rules, even detecting or proving whether there is or isn't a policy oscillation is NP-complete. So it's a hard problem to actually prove. But in this example, we're going to have one. Okay, I'm further going to say, so if you look at every one of these ASs, you have two possible paths going to 0. One is your direct path to 0, and the other is your path through this one indirect provider. So, for example, 2 here can go either 2, 1, 0, or it can go to 0. And we're going to say that every AS prefers the indirect path over the direct path. If I can route not going directly to 0, then I prefer that route. Okay? So if you look at what happens now, let's say at the beginning of time, everyone only knows their direct route. So 1 thinks it's going to go 1, 0, 2 thinks it's going to go 2, 0, 3 thinks it's going to go 3, 0. Now let's say 1 advertises this route 1, 0 to 2. Okay? So what route is 2 now going to pick? AS2 has 2 options, 2, 1, 0 or 2, 0. Yeah. So 2, remember we said everyone likes going through an intermediate path, AS on the way to 0. So 2 is going to say, I prefer the path 2, 1, 0. Okay, 1 is still doing 1, 0, 3 is still doing 3, 0. Now 3's advertisement of the path 3, 0 reaches 1. Yeah? So 1 is going to do the same thing. It's going to say, I like the path going to 3. Does this step make sense? Yeah? So what is it going to do at this point? It's going to withdraw the route 1, 0. It's going to tell 2, I do not have that path 1, 0 anymore, because that's not the path it's following. So what is 2 going to do now? 2, 1, 0 was just taken away. What is 2's path? 2, 0, right? Now let's say 2 advertises to 3. The path 2, 0. 3 says, I have a nicer path. 3 now goes 3, 2, 0. What does 3 do now? It withdraws the route 3, 0. It's not using it anymore. So what does 1 do? Go back to 1, 0. Right? What is 1 now going to do? We're going to go around in circles, so this should be, at some point, should be easy. Any takers? What is 1 going to do? It's going to advertise 1, 0. What is 2 going to do? It's going to say, I like that path better. It's going to go 2, 1, 0. Point is, 2 is then going to withdraw 2, 0. 3 is going to go back to the straight path. We are back exactly where we started. Right? This could go on and never settle. Does this make sense? Would anyone want me to repeat it, or went okay? Okay, so yep. Why does AS2 prefer 2, 1, 0 over 2, 0? That's your policy choice. We're not saying it makes sense. We're saying that was the policy chosen. So the point here, notice, this was not about loops, right? No AS ever picked a path that had a loop. It's just that you couldn't settle on any one route. Every one of those routes you picked was a valid route. You did the right thing. You picked a route that was advertised. You withdrew a route when it was no longer in use. Those routes never had loops. They all followed customer-provider relationships. It's just that you kept going in this circle. You were oscillating on which route you were picking. Okay, so that's an example of a policy oscillation. Any questions? Why you, sorry?
Is there a particular reason that the policy oscillation is bad?
Yeah, so that's a good question. Why is this bad? So we keep changing our mind, but they're all valid routes. Why is this bad? The reason goes back to some of Murphy's examples when we were doing distance vector and route calculations. When routes are changing, you sometimes have loops that form because I think I have my next hop is you. You think your next hop is me. So until routes converge during times of change, there's always the possibility of dropped packets or dead ends or loops until routes converge. And in this case, they're never converging. Okay?
So I don't know if this is beyond the scope, but is there anything designed to when this happens, use a route?
One of the things that so I should say this is a little bit of a theoretical example. I don't think anyone has ever, that I know of, on the internet found a case where people in a valid, deliberate configuration ended up in a world like this, because you tend not to have these loops in these cycles in the customer-provider relationship. What we have seen are oscillations that happen because an operator misconfigured something. And so they didn't mean to do it, but they did it. What has ended up happening in practice is that because people are a little scared about getting into these bad scenarios, they slow down the rate of change of BGP. So there are all these damping timers that will say, don't change. If you changed in the last X minutes, don't change again. And so it kind of gives an operator, I think, time to catch if something's going wrong. It's not the most ideal situation, for sure. Question?
Under Galveston, if you have multiple routes to a destination, are you required to advertise all of them to the
You are required to always select a route, so that avoids dead ends. And in export, if it's a customer route, you're required to export it everywhere. Also notice GovExpert doesn't give you a unique path. There's still like amongst which provider you're going to pick, that's up to you. Any other questions? Why does this violate GovExpert? Because 2 is a customer of 1, 1 is a customer of 3, and 3 is a customer of 2. So it's a cycle in the customer-provider relationship. You don't have to advertise all your routes. You have a route to a customer, and so you advertise that. So here I am advertising. I always am advertising 1 route to 0. No. Sorry, was that the question? You don't. No. I do need to advertise a route to a customer to everyone.
Are policy oscillations like this, are they always periodic?
Periodic as in...
This is sort of rotating. It's eventually kind of there's a time period when you're first state here.
So if you mean there's a certain sequence of events that's happening that's leading to a policy oscillation, or in this case, I think maybe you're saying that it's always a loop of 3. We're oscillating around a loop of 3. It depends really on the topology. But we don't actually know, not that I've seen even in the research literature, a result that tells you how to find a policy oscillation. We have examples of them, but given a graph and all the possible timing of events and the possible set of advertisements, actually finding an oscillation in a short amount of time is not something that I think we have a result for yet. Any other? Okay. So moving on from routing, the last, 3 weeks now have been about what is kind of the control plane of the network. How do we compute these routes that we're going to follow? We're kind of done with that. We're moving on now a little bit more to the data plane and talking about what IP packets actually look like, what is the architecture of IP routers, a little closer look at what they actually do inside an IP router, what exactly is it doing. So today's topic was designing IP. Probably wondering, what does it mean to design a protocol? If you go back to the very first week of class, we talked about this means you define the syntax of these messages. I have 4 bits for this, I have 8 bits for that. Not very exciting. But also more interesting is the semantics of these messages that we're exchanging. Okay? So what types of messages, why do we have them? What actions are you supposed to take when you receive them? For today, we're focusing on the IP packet and designing the IP packet. What this means really is designing the format of the IP header. Remember, at the network layer, we don't look at anything inside or deeper than the IP header. So we're really just going to look at that IP header and talk about what it looks like in terms of syntax. We're also going to talk about why we have those fields, what's the meaning of those different fields in the IP header, and what processing needs to be done on that IP header. I have to say you can approach this lecture one of two ways. You could approach it as I need to learn that there are 8 bits for this and 16 bits for that and 4 bits for the version. This will probably be the most boring lecture you've ever attended. The more fun way to approach the question is to say, why does the IP header look that way? Okay, think of it as an interface, the interface really to the internet. And so think of it in terms of how would you design it. Okay, and use that to help you understand why IP is doing things a certain way. And the IP header or the IP API is by no means perfect. It's done a bunch of things not very well that have just been hard to get rid of, so you can probably come up with a better design, in fact. So, and one point to note also, we're never going to expect you to remember or memorize the IP header. Every midterm, every exam, we're going to give you the format, the syntax of the IP header. So the emphasis really is on understanding why it looks the way it does and where it falls short and where it's done well. Okay, so with that, just a few things to remind you because it's been a few weeks now. We talked about layer encapsulation, where you start at the application layer, you add an application layer header, something like a HTTP header, then something like a TCP header. Then you go down to layer 3, which is what we've been talking about, or the network layer, and you add an IP header. Pass that down where you add a layer 2 header, goes out, and on the receiving end, you strip these headers as you go up the stack. We also had this complicated protocol diagram where we have semantically at different layers, you agree on what the conversation is between the two endpoints. And our focus here is really going to be on the network layer. Okay, so that's the implementation of IP at the end host and at routers and at the receiving end host. So that's our focus for today. So with that, think of the IP header as an interface. It's an interface because the IP header is the one interface we have going across all entities, the end hosts and the routers. So you can think of that IP header as an interface going both to the network and to the destination end host. The interaction that your IP packet has is slightly different in the router versus the end host. So let me just recap that very briefly. So think about what your layer 3 header does at your router and at your end host. So the highest level, all we've talked about so far is your layer 3 header has a destination IP address, layer 3 address. When it reaches a router, what is that router going to do? It's going to pick that packet up. It's going to say, am I the destination for this packet? Most likely it's not, because if you remember Murphy's lecture, you very rarely send messages to a router. So it's going to say, I'm not the destination. This packet is still on its way. It's going to forward the packet out. How is it going to know where to forward it? That's what we've been talking about with routing. Okay. When you reach the destination at the end host, you do something a little different. Hopefully you look at the packet destination and you say, am I the destination? And you say, yes, I am. And so what do you do at that point? You hand it up the stack. Right? So when we talked about layering, we said you hand it within your operating system, you hand the packet over to the piece of code that implements layer 4. That's usually TCP. And then from there, it's going to get passed to the application. Okay, so when we're talking about designing the IP header as an interface, we have to put into that header all the information that's necessary to handle that interaction both with the routers and with the end host. Okay, so with that, very, very high level, again, going back, when you design an interface, and this is something you do all the time when you're working on your projects, writing code, how do you typically approach it? You think in terms of what task am I trying to achieve with this function or module that I'm going to invoke? And then what information do I need to pass to that module or that function so that it can do that task? Right? Does that resonate? And so the header is really what information do I need to pass to the network so it can do its job, and what information do I need to pass to the destination end host so that it can do its job. Is that kind of setup clear? So we need to think in terms of what tasks are we trying to do at the network layer, and what information do we need in order to achieve